Okay, in this video we're going to go over the Python 3 subprocess module. What the subprocess module allows us to do is to run underlying operating system terminal commands. Okay, so this is really handy because most terminal environments have an incredible number of commands available, and it can be very useful to just toss one of these in. There is a downside if you want your script to be portable, that is to say if you want your script to run across multiple platforms, if you want it to run in Windows and Mac OS and Linux, for example. You will have to be careful about using subprocess because the commands between the systems are not the same, right? Windows has a different set of terminal commands, right? So anytime you use this, you do need to be aware of that. It is something that you can potentially code around, but in general, if you use the subprocess module, you're probably just going to be stuck with one platform unless you do some extra work and find the right commands for other platforms. Okay, that said, it is really handy and really nice to be able to do this. Okay, so here is the subprocess documentation, this module. This type of thing has gone through several iterations in Python, so subprocess is sort of the latest way of doing this. And you'll see here we have subprocess.run. There's arguments and all sorts of kwargs, keyword arguments that you can specify, and we'll just talk about the basics. So this document is really good to look at. However, it is rather complex, and there's a certain amount of history from previous iterations. As it says here at the beginning, module intends to replace several older modules and functions like these, right? So it is good to get exposure to documentation, though. So let's move over and try to build something here. Let's go, we're going to go new file, we're going to call this subprocess. And this is just, subprocess 1.py. Okay, now I like to use the hash bangs for my files, and if you do that, you need to add this line at the very top. This is mainly for Linux, and this is only for Linux and Mac OS. And then I can change the mode, which is the chmod permissions. So this is going to make this file executable. And all this does is basically allow me to say, print hi. So if I've done this, added the hashbang, and made my file executable, then I can just open up a terminal. Let's resize this a little bit. And now I can just run this file like this, right, with the / instead of having to say Python 3 subprocess. So you don't have to do what I did there. If you're in Windows, you're going to have to probably do something like this. Instead of Python 3, it'll probably be Python. But I prefer to do this, so you'll see that throughout this video. So anyway, subprocess. All right, let's get down to it. Let's try to import that module. Import subprocess. Okay, what do we want to do here? Let's try something simple. Let's say subprocess.run, and this is going to allow us to run a command, and that command is we can say is ls, or we could say is the echo command, and we could say hello, right, something like this. All right, now I can go back to my terminal window and I can just run subprocess1. Okay, no such file or directory. Okay, so it doesn't like this directly, right, because I have left off a keyword argument. Shell equals true. Okay, now there's sort of two ways to run these subprocess commands. Okay, either with the shell or without the shell. So in this case, the entire string is the command I'm trying to execute, and so I have shell equals true. Okay, now that works. The echo command is generated. It's the same as me saying, exactly what I have typed here. If I copy and paste this into my terminal shell, I get the exact same result. Right? Okay, so the first argument is a string if you have shell set to true, and you can even do things like variable interpolation, right? So we know that when I run this command in the terminal, the shell actually before the echo command is ever executed, the shell looks at this argument and says, oh, that is a environment variable, right? That's an environment variable, so I need to swap that out with the value that is held there. And then it also sees this tilde, and so the shell goes ahead and does tilde expansion. The tilde character expands to the absolute path of your particular logged in user. So when I run this, we see hello Luke instead of hello user, and we also see instead of the tilde, we see my home directory, right? Similarly, when I run subprocess 1, I get the same results. And again, that's because of shell equals true. Now, if I get rid of the shell equals true, this style is no longer the appropriate way to run something, right? What it wants now is it wants an array. So I could say echo, and that is the command, and then each argument afterwards is the argument to that command. Now watch what happens when I type in user here. Okay, it does not do the variable expansion. Okay, so if you want any of the neat features of a shell, like tilde expansion or variable expansion, you're going to need to say shell equals true and change the way you create this. All right, so for everything we do, we're probably going to want to use the shell just because we're most familiar with it. So we're going to have a command echo hello, and then $sign user. And we also have to escape certain characters that are that the shell recognizes as special characters, right? So we have to escape the exclamation point. And here we just say shell equals true, right? And now we can run this again. So one other thing to notice here. So we get the user instead, and we do indeed get the exclamation point. One thing to notice here is that we are not getting our output stored anywhere, right? This subprocess object does store, there is some resulting objects, but by default, this object is not particularly useful to us. So we can take a look at this. I'm going to add a little separator line here, and I'm going to say print, and let's look at what's inside of this object, right? So if you want to look at the attributes associated with an object, you can use the dir command, right? So we can look at that. So this results object has all of these attributes. Okay, we could also look at this a little cleaner, and we could say, oh, let's see, the ending character is the new line, and what's the in-between character called? Print end. Oh, we should look that up real quick. Print command end and in between. So there's a special keyword argument, so you can look up keyword arguments end equals, and that's the ending point. By default, it is the new line character. We want documentation. There we go. Print. There we go. Global functions. That's a really good page, by the way. It shows all the global functions. SEP, separator. All right. Sorry that took so long. I couldn't remember it, and it was going to bother me. So anyway, look that up real quick. The separator is usually the space. So when we specify a whole lot of items together in the print function, if you have a lot of things separated by commas, the separator is a space. Right. What we're going to do is make the separator a new line, so these print out one per line, and we're also going to use this little asterisk here, and this is going to separate all of the items in this list as individually as arguments to this print command. Okay, so it's gonna, instead of printing out a list here, each one of the items in the list is going to be a direct argument to print, and then the separator is a new line. So this is sort of a side note. Slightly advanced, not too bad though, but this is going to make it so all these print out one at a time. Okay, So now we get a sense of what this object is. The double underscore values are usually reserved for Python, so you'd probably want to be more careful with those. But we see we have a standard error, standard out, and a return code, right? And arguments. So we can kind of look at what these things are. We can print out. Now remember, this res object is just the result of running this, okay? Now if we look at this, we're not going to see anything in standard out or standard error. We will see a return code, and that is basically the underlying system code as to whether or not the program succeeded or not. Alright, so let's add some separators there and see what we have. Alright, so we'll run this again. So there's no standard output and no standard error. Okay. Well, if I want there to be, then I need to add another kwarg. And so I'm gonna make one argument per line here, because this is these arguments are gonna get a little bit long. So we have capture output, and we're gonna set that equal to true. Alright, and we can run this. Alright, and we have this funny little string, right? B, that means bytes. Okay, if it's it expects the output to be bytes, and also the same if you want to include any input, which we're about to get to. So to make sure everything we're dealing with is text, we can just say text equals true, and that's going to default to, I believe, UTF-8, which is the most common sort of ubiquitous character encoding. All right, so now if we say test equals true, I'm sorry, text equals true, then we can see we are capturing the output, right? So above here is where we ran the command, then we printed out all of those individual items, and then we printed out the standard out. Okay, so remember, the standard out included a new line character, but then our print command also included a new line character. So we could change that with end and set that equal to nothing. Same for this. Okay, so there was no standard error, but we did collect the standard out. Okay, and so the only reason this is being printed is because we printed it. So this is useful if you want to run the command, but you don't want the output going to standard out. You want to do something with the output afterwards. For example, if you were listing out a listing of directories or something like that, and you wanted to manipulate those values after you got them before you just print them out to the terminal, right? So you want capture output to true, and then on the res object, these things are going to be filled appropriately. Okay, so you need shell, capture output, and text for most use cases, and then this is going to be your command that you run. All right, so that's a simple subprocess one. All right, let's take a look at a different example. What if we want to create a file and run that file? So we have one program that we want to run with another program. Okay, so let's do something like that. So we're going to have new file, and we're going to say args1.py, and this program is just going to allow us to get some arguments. So change mode 755, that makes it executable. env3. Again, you don't need to do this. You can just use the Python command if you want, but this is my preference. And we're going to import sys. Okay, sys is going to allow us to get the arguments. So print sys.argv. That stands for argument vector. Now, if we print this out, we can see args1. So this is our argument vector. It's a list. So vector, you can generally just think of as an array or in a list, right, in Python. So any arguments I add here, and then each argument is an element of this argument vector, the argv array. Now notice, because I put quotes around here, the shell recognizes the quotation marks, and it has a different set of rules for what's inside of quotation marks. Namely, the most important probably is adding a space character that is actually included in the argument instead of these being treated as separate arguments. So if I take away the quotes, we see that they are treated as individual arguments. Also note that the program itself is included in this argument vector. So we very rarely need that. So I'm going to split that off. So I'm going to say args equals sys.argv, and I'm going to take a list slice, and I'm going to go from the beginning, the first element of the list. So the beginning element would be 0, but I'm going to go from the first one because we don't want that first program name in our list, and then a colon, and then whatever's if I leave that blank at the end, it's going to go to the end of the list. So this is just going to slice off all the args. Slice off that, I'm sorry, it's going to slice off that first argument from the list. Okay, so I got rid of this guy here. So now what we can do is just have a nice, simple, for arg and args, print arg. Right, nice and simple. And above here you could have something like, if dash h is in args, or dash help is in args. You could have some help messaging, right? Program to print args, and you could list out the options, right? Print options. This is all not particularly necessary, but you could, you should get in the habit of doing this for any of your programs that are going to be run from the command line. So you could have the options dash h and dash help, and you could say print this help text. Okay, super common stuff you should probably do. And if your program does print out the help text, it should exit afterwards. Say exit 0, right? Because that's its job. When you add either of these options, it should exit. Okay, so let's see if we run this again. We can say args1 apples. It prints out apples. What if we say dash h? What about dash help? Okay, good. So that's working, right? And so any arguments I pass, unless they're the specific options, right, are printed out. Very simple program, arguments, okay? Now what we want to do is we want to call this program from our subprocess, okay? So let's make a new file, and this is going to be args.py. All right, we should be very used to making our hash bang and changing the mode. You can do that with the chmod command as well. And so here what we're doing is importing subprocess. All right, and we can just peek over here and remember these are the three things we want. We want shell, we want capture output, and we want text. So I'm just going to copy and paste to save some time. Okay. But one thing I want to find out is I need to figure out what file I'm talking about. So I want to run args1.py. Okay, so this is the command that I want to run, right? I'm looking in this current directory. Now it's important that we recognize // is the current directory of the terminal. It's not the current directory of this file, and I'm going to elaborate on that in here just a second. So I can run this and pass in any of the arguments that I want. Now because this is all in one string, I'm going to have to escape some of the quotation marks, and then I can say banana split. All right. Now I've got capture output on, so what I need to do is print the result.standard out. and it should have an additional new line character at the end. So I'm gonna say end equals no empty string, so that way the print command or the print function doesn't print an extra value. Okay, so that's what it should print out if you ran it from the command line. Let's run subprocess, .args. Same thing. Okay, now we've captured the data in result.standardout, right? And notice that there are new lines in it. So if I wanted a list of individual lines, I could split this over the new line character. All right, let's try one more. We've got a couple more we got to do. I'll try to move fast here. New file, and this is file versus working directory .py. Okay. So what is the difference between, I mentioned, I could run this program and from the current working directory of the terminal, but what if I want to know, I want to reference something relative to this particular file's path, right? So there's two different ways to do this. So let's look at this. Let's import OS, and I can say print os.print path dot, I think it's pwd or cwd, current working directory. All right, and I believe that's a function, so we'll find out here in a second. We'll go back and run this, and we'll say file versus working dir. So it's os dot current working directory. All right, let's look it up. Current working directory. So os.get current working directory. Current working directory, it's something like that. Okay, so get current working directory. So what we do is get current working directory. Now we can run this again. All right, so the current working directory. Now notice that is where my terminal is located. My terminal is located in the desktop. So if I change directories to my parent location, right, and now I'm in my home folder, from the command line I can say pwd and get, see, notice I'm not on the desktop anymore. If I run this program though, so I can still run this program from a relative path, okay, here we see that my working directory has changed. So get current working directory, that is relative to the terminal. Okay, what if I want the directory that my file is in? Okay, well there's a couple manipulations we can do here. __ file __ is a relative path from your current working directory to this current file. All right, so we're gonna this is the relative path to this file from the current working directory. And we'll take a look at this. Okay, so here's my terminal working directory, no longer in the desktop, but notice the __ file variable holds the relative path from where my current working directory is. Okay, so one thing I can do is I can get the absolute path. And to do that, I can use the OS library, has a module .path, and I can say .abspath to get the absolute path. Okay, so now instead of this relative file, we have the absolute path. And so this is what you're going to want to do if you ever need to reference this particular file in your program. Now, what we're going to want to do is reference a particular file in this directory. So we, instead of the actual file, what we want is the absolute path to the containing directory. Okay, so what we can say here is print os.path.abspath, and then pass in our file. Right, but this just gives us the absolute path of the file, so absolute path of script, or the file or the program. So what we need is os.path.dirname, and this will give us the directory name, and since it's already an absolute path, it just truncates any file name afterwards. Okay, so now we have access to this dir name. So now, once I have that, then I can use that to print out or to run one of these other programs. So for example, subprocess args, I can't run this because I'm using // here. So that means wherever my terminal is located, it's going to look inside of that directory for args.py, args1.py. But that's on my desktop. So if I try to run this, desktop args1, we get no standard out, and we should also get return code let's see, result return code. Oh, I need to run subprocess args. Subprocess_args. Okay, so we get a return code here, which is, it's a non-zero return code. Zero return code means the program worked. Non-zero means it failed. So that just means we don't get any standard out because this didn't work. The reason it didn't work is because there is no args1.py program in my home directory. If I list this out and grep for args1, that program doesn't exist. There's nothing in here called args1 because it's in desktop. So we can ls-l and then grep for args1 in the desktop folder, and we do have an entry. Okay, so all of this is to say, because I did this with // that means when I run this command, I am running it. The // has to do with where my terminal is located and not where this file is located. It's a very confusing thing. It comes up a lot, so it's very important that you know the difference between that. And I know that's sort of a long tangent, but it's sort of critical. So now that we know that, for subprocess.args, what we can do is we can take our absolute path to the parent dir, right, which is os.path.dirname, and then take os.path.abspath, right? So we can put this back into subprocess.args, and we can say it's this, and then we can say we'll make this a format string, and we'll say file dir. Right, there's a better way to join things together with paths. You can use os.path.join, right? But for this, we're just going to do this because it's easy. All right, and so now what this has done is I can now run this program from any other program, and it's always going to run args1 from this directory. It's going to, this file dir is my desktop, or wherever actually this file is located, and then it's always going to look in the same directory that this file is located in for the args1 file. Okay, so now we see before we got an error code when I ran this command. Name OS is not defined. Import OS. Okay, now we see it does indeed run everything fine, and it also includes a 0 status code. Okay, the return code is 0. Okay, so that's very important. Now there's one other thing that you may want to do, we're going to make one simple program. It's going to be called input1.py. And the idea here is we're just going to use the input function to get information from standard in. All right, so this is something really common that you'll want to do. We can right click on this and change the mode, 755, and import. Let's see, we don't need any imports. So we're going to get some data. So user data, and we're going to get that from the input command, and we're going to say enter some data, empty string to quit. Okay, we leave a little space here so the presentation is nice. When it asks us this, we can say while user data does not equal the empty string, we're going to go through, and what we want to do is we want to add this user data to some list, right? So I'm just going to have an li for list, and if it's not the empty string, then we're going to just add it to our list with append, li.append user data, and then so this is sort of called priming the loop. We run this, but then we have to do it again at the bottom of the loop. All right, so enter some data, empty string to quit. Okay, so now whenever this, eventually the user is going to type, just press enter, then user data is just going to be the empty string. As soon as it's the empty string, we'll break out of the loop. And so for item in user data, or in li rather, we're going to print that item. Okay, so really simple program. We should all be able to do this pretty easily. Let's run input one. C desktop. Mod plus X, input one, just to make sure it's got the executable bit set. Input one. So now I can type things: apples, oranges, banana split. And then as soon as I press enter, we stop collecting in that loop, and we have in our list apples, oranges, and then banana split. Okay, so now what we want to do is we want to call a subprocess, but we want to provide the input, the standard input from our program instead of from the command line like this. Okay, so I'm just going to duplicate this subprocess underscore args, and we're going to make this subprocess underscore input, because most of this stuff's going to be the same. Okay, we still need the file dir, and instead of args1, we're going to say input.py. Now this is the stuff that instead of being an argument, we're going to get from the standard input, right? So what we want to do is we want to say input equals, and with standard input, whenever we type something, so I would type out apples, I had to press enter, and the enter key actually adds a new line character. And then I would type something else and press enter, and the enter key actually adds a new line character to the standard input stream. And then banana split and press enter, which adds a new line character. So what I need to do here is, instead of these spaces, I'm going to add the new line characters to mimic pressing enter, right? And I don't need, there's no shell expansion, so I don't need these quotes, right? This is just standard input. And I press enter after banana split. Now there's one thing I have to remember, because I need to press enter one more time, because I have to press enter to quit, right? So I had to press enter one more time here on my standard input stream in order for it to quit. All right, and so we need a comma here, and we're still capturing the output, and we've got the standard output and then the return code. All right, and so we'll see what we can do here. We'll see if this is chmod plus x. All the Python programs good. Now we want to run subprocess input. Okay. So notice the standard output, because we use the input command here, this actually prints this to standard output. Okay, so we have that captured. So that's sort of a problem you might have to work out with some of your programs. So every time it's asking us for the data, right, but then our program automatically puts it in, and it keeps asking us each time. And then here finally it prints out apples, oranges, banana split. So there are still plenty of things you can work on and try to figure out how to do on your own, how to correct these types of issues. But this is the basics, the general concept of what we're trying to do here is running using the subprocess module. We're trying to run underlying operating system commands from within our program and being able to manipulate the results. Okay, so this should be a pretty reasonable introduction. Sorry it went a little bit long. There's kind of a lot to walk through. Okay, but this should definitely get you started. And do take a look at the documentation page, because there's a lot of good information there. It is a little bit complicated though, so take your time with it. And do these examples. Make sure, just to make sure you understand this stuff. You always understand it better when you've done it yourself. Okay, so that should get us for this video. Thanks for watching.